This is chapter 1. The subject is logarithms. Now on exercise 2, solve each equation for x. Means that we will not reach the value of x, but we will write the equation in the form of x equal. This is the meaning of for x. So as we have here on A, we have 3 power x equal 4. This is just an exponential form of the equation. So we just transfer it to logarithm form. It will be logarithm 4 base 3 equal x. Now this is a solution for x because it is in the form of x equal. B, 2 power x plus 1 equal 3. We also have it in an exponential form. So we transfer it. It's going to be logarithm 3 base 2 equal x plus 1. Now we transfer the term of 1 to the second or to the other side of the equation. It's going to be x equal logarithm 3 base 2 minus 1. C, we have 3 power 1 minus x over 2. This is equal to. Again, we use the logarithmic form. It's going to be logarithm 2 base 3 equal 1 minus x over 2. And again, we transfer this term. It's going to be x over 2 equal 1 minus logarithm 2 base 3. And you can check how the signs changed for the terms. And now, this is x over 2. I need to make it just x. So we multiply the whole equation by 2. It's going to be x equal 2 minus logarithm 2 base 3. On D, we have square root of exponential function power x equal 4. So in order to transfer terms and make them in the form of x equal, first we write the square root in the form of x over 2 equal 4, and then change it to logarithmic form. This is logarithm 4 base e equal x over 2. Now we just want to reach x, so we will multiply the equation by 2. This is going to be 2 logarithm 4 base e equal x. And for any logarithm, if the base is e, so this is the natural logarithm ln. So we write 2 ln 4 equal x. And this is what we wanted in the form of x. E, 10 power x equal 5, exponential form, very easy. Just directly make it logarithm 5 base 10 equal x. And the last one, if 10 power x minus 1 equal 2, also this is logarithm 2 base 10 equal x minus 1, and then we transfer the term of negative 1 to the second side. It's going to be logarithm 2 base 10 plus 1 equal x, and now we reached the equation in the form of x. Now in exercise 3, simplify the expressions. So simplifying means that we need to reach the simplest form. We may reach the value of x maybe sometimes. Okay, now in A we have x. So the question is e raised to ln x. Now we will work on the exponent. We will say ln x equals y. This is now a logarithmic form. The ln is the natural logarithm, so this is logarithm with base e. So y equal logarithm x base e can be written in the form e power y equal x in the exponential form. Now what is y? Y is ln x. So e power ln x Now, as we know that the ln is logarithm base e, so e with logarithm base e for x, the result is x. How did we do it? We just remember the fundamental identity saying that a power y equal x. That's if and only if y equal logarithm x base a. So we get a result from them as a power logarithm base a for x equals x. So the base and this base are the same value, just the same here. The base of ln is e and this is e, so the result is x. On b, we have 10 power logarithm 3. Again, we will work on the exponent. Let m equal logarithm 3. I know that if there is no base, so the base is 10. So we will rewrite it in an exponential form. It's going to be 10 power m equal 3. So then, 10 power logarithm 3, the given, equals 10 power logarithm 3 base 10. Now just we viewed the base. And then the base here and the base of logarithm are equal. So then the result is 3. Now in C, 4 power logarithm 7 base 2. Again we will work on the exponent. Let n equal logarithm 7 base 2. Rewrite it in an exponential form. This is 2 power n equals 7. Now we back to the main formula. 4 power logarithm 7 base 2. As we know that 4 can be written 2 power 2. And this 2 is going to be the exponent of 7. So we will read it as 2 logarithm 7 power 2 base 2. And 7 power 2 is 49. So then 4 power logarithm 7 base 2, here it is, it equals 2 logarithm 49 base 2. And as the base here is 2 and the base of logarithm also 2, so they are equal, then the result is 49. On H, we have negative logarithm out and logarithm in. So we are sure that we will work starting from the inner values. In order to use the logarithm here, we need first to simplify this expression. So 3 under the fourth root is a 3 power 1 over 4. And under the second root, this is power 1 over 2. So multiply 1 over 4 by 1 over 2. It is a 3 power 1 over 8. Now I see that I have logarithm 318 base 3. As we knew, if those two are equal, just transfer the 1 here and make it multiplied by the logarithm. So the result of this expression all is 1 over 8, because this is going to be equal 1. So we will have minus logarithm base 2, which is the outer logarithm, for 1 over 8. And 8 is 2 power 3. We switch it, it's going to be 2 power negative 3. So we will have logarithm 2 power negative 3 base 2. Also you have like values, and this reminds us by this expression and this the property. So negative 3 will be multiplied by the negative out here, and the value of logarithm 2 base 2 is equal 1. And then negative 3, the result is going to be 3. In exercise 4, calculate the logarithms. So calculate means reach a value. So First one, logarithm 18. Before we start, we find that given to us the values of logarithm 2 and logarithm 3, there is no base, means that the base is 10. So we will use them in calculating. Now, logarithm 18, of course, we will try to factor 18. So this is 9 times 2. And as we know, if we have multiplied values, so we can separate them by adding logarithms. I can say for students, when we multiply numbers, we add logarithms. Okay, so this is logarithm 9 and logarithm 2. For logarithm 2, this is easy because I have the value directly, I can substitute it. But for 9, I need to make it a 3 power 2, and then this 2 will be multiplied by the logarithm. This is 2 times. Logarithm 3 is given also. So I substitute 1.4771 plus logarithm 2.30103. First, we will multiply 2 by 0.4771, and then we will add 2.30103, and this is the answer. For B, we have logarithm 30. 30 is 10 times 3. Multiplying the numbers is adding logarithms. Logarithm 10 and logarithm 3. For 3, we have the value. And logarithm 10, as we know, the base is 10. So 10 and 10. So the value of the logarithm is 1. 1 plus 0.4771, and this is the result. On 5, logarithm 1, on C, logarithm 1 over 5, this is logarithm 2 over 10. Why? Because 1 over 5, I don't have the value of logarithm 5. Logarithm 1 is 0, and this is easy. But for 5, there is no any information even in these values. So I will give the equal value to 1 over 5, which is 2 over 10. Then it's going to be, when we divide numbers, we subtract logarithms. So logarithm 2 minus logarithm 10. This is 10 to base 10 and equals 1. And logarithm 2 is given to us 30103 before after the point minus 1, and the answer is 0.689 69897.